Hi everybody, Sawyer is here to help me answer or not answer. He's not helping. Sawyer not helping. Answer a question about buffers and followers from 285. Somebody posted online. It's a really good question. Why is it that we need a voltage follower or buffer? And then I answered something like, well, you need it because the load is going to be a resistor. So let's say there is a circuit with a nodal voltage of any kind, and I simplified it by putting two resistors there or a potentiometer. But really, this could have been any other, let's say I said there was 5 volts here, and let's say there's 2K here, and there's 2 kilo ohms here too. But it could be a super hard circuit on this side, hard and complex circuit. But I want to make it the simplest possible one to show you what happens. This nodal voltage here is 2.5 volts, right? It could also be any other voltage. It could be any note in your circuit. But really what matters is how much resistance between that voltage and ground is. So just for the sake of this example, I'm going to call this 2K, but it could be something else. And the objective is for this 2.5 volts to be used in another circuit. So this would be input to a circuit. Let's say you find an op-amp, or you find a microcontroller, or it could be an op-amp, it could be a speaker, it could be a motor, it could be a microcontroller, it could be any other chip. It could be, if this were 5 volts, it could be a TTL gate. So it could be a gate like a 7404, 7400, which is an AND gate. If you're taking EC231, you're memorizing those 7408, 7411, 7474. It could be a flip-flop. So, of course, I don't know that they make gates that are powered by 2.5 volts. Whatever load, it could be an LED. It could be a light bulb. So it doesn't matter. Well, it matters a little bit which load you want. You're powering, or you're using this voltage to do something in your next circuit. And let's say I tell you whatever you're using that for, this thing here needs 25 milliamps of current, which is very low. Usually it's much more than that. So if I have a voltage of 2.5 and this thing we will use 25 milliamps, the equivalent resistance that I will see in this circuit here, this equivalent resistance that I'm making up, will be that 2.5 volts divided by 25 milliamps. And this is 2.5 by 2.5 is 2.5 by 25 is 0.1, and milli goes here as K. So this, let's say it's 100 ohms that I am looking. So when this voltage goes into it's not really goes, it falls across my circuit and the ground, and the circuit is using 25, it needs 25 milliamps to actually run, like the motor to run, the microcontroller to work, the LED to turn on. You probably have a resistor in parallel, in series with LED. Let's say that resistor is 100 ohms, which means that 2.5 volts to provide 25 milliamps needs to be 100 ohms. So the equivalent circuit that we are going to have will be this huge circuit with some other huge circuit that I don't know, with these 2K here and 2K here, and somehow this is 5 volts. And then that other huge circuit, I am using instead a 100 ohm resistor as a placeholder or as a model for my motor, light bulb, LED plus resistor, op amp, gate, microcontroller, microprocessor, a little robot, a car, little car. As soon as I put this 100 ohms here, what happens is that the equivalent circuit immediately becomes this 2K in parallel with the 100 ohms. And this circuit goes then to 5 volts, 2K, and then a resistance that's less, and then a resistance that is less than 100 ohms, but it's more or less 100 ohms. It's really 100 times 2K divided by 2.1. It's more or less 100. And I'm writing ground here. So then what happens is that the voltage here from 2.5, it goes to, it's, 100 ohms is 5% of this, so it's almost 0 volts. Basically, you cannot provide, with this circuit here, you cannot provide 25 milliamps to this load at all. So the fix to this is, when this happens to you in your senior design project, fix it. The buffer is what you have to use necessarily. So if you have that same circuit, like this 5 volts is coming from a complex circuit, spits out 5 volts here, and then you have 2K, you need to necessarily put this into a buffer, and then you can put 100 ohms here, or any other thing, or your microcontroller, your op amp, whatever this, any of these here go here, speaker. And so these 2.5 volts, you guarantee here 2.5 volts, and you guarantee that in principle this op amp will provide you at least 25 milliamps. So usually op amps will go to 50, but you can design the op amp so that you have enough current on the output that can deal with the load. If it's a speaker for your car, you want to use an audio amplifier that will put out at least 1 amp. If it's a small motor, you take a look at how much current it needs, which voltage, and then you can even change this voltage and it will change it here. It will not be using any current from your original circuit and will provide its own current that really comes from, you giving power to the op amp. So plus minus VCC really is where that current is coming from, but the op amp is designed to provide however much current it says on the data sheet. So this one is designed to provide no current. So I want this current here, I equals 0, which is one of the rules of the op amp actually. So I am not using anything from any current from this circuit. The current will continue to go. This is a series circuit. It's a voltage division. I hope this clarifies the question you guys had, which was a really good question.